Welcome student. In previous video we have seen that the example of vector space. In this video we are going to discuss the definition of subspace. But before the study of subspace we know that the term is a subspace. That term is a subset. That term is a subset. What is meant by subset? We assume two sets. One is the set A and another is a set B. What is meant by subset? That means that all the elements of set A, is an element of set A. That means set B is a subset of A, and this is known as a definition of subset. Means all the elements of set B is an element of set A, and that is the B is a subset of A. This is the term subset. Then we are comes to the point subspace. The definition of subspace. Let V be a vector space over a field K, and let W be subset of V. That means W be a subset of V. That means all the elements of that W is an element of vector space V. Then W is a subspace of V. That means W is a subspace of V if W is itself a vector space over K. Why? Because W is a subset of V. That means all the elements of W is an element of V. Then W itself a vector space over K with respect to vector addition. Vector addition and scalar multiplication on V. This is the definition of subspace. Let's one theorem we are the given, and that theorem is W is a subspace. W is a subspace of V if and only if first W is non-empty. Second, W is closed under vector addition, then V plus W, small w, belongs to capital W, V, W, that belongs to W. Then third, W is closed under scalar multiplication, then Kv belongs to W, small k belongs to capital K, and V belongs to W, because W is itself a vector space, and that U plus V belongs to that vector addition and scalar multiplication. We are use the following examples. Then we are see the corollary. one corollary. W is a subspace of V if and only if first W is non-empty, second V comma W belongs to capital W and A comma B belongs to capital K, then AV plus BW that belongs to W. These are the corollary, and we use the examples. Then let's start the examples of vector space. Let's start the example of vector space in example number first, and that examination is important for the examination. Okay, one of the example are in the question paper of M.Sc. part 1 physics, paper number 1 M.M.P. Let's start the example. Let V is equal to R cube full stop determine whether W is a subspace of V where W is equal to in bracket A comma B comma C slash A square plus B square plus C square is less than or equal to 1. Set complete. Then problem we are given, problem is the determine whether W is a subspace of V. To show that W is a subspace of that V. Okay, we are solve that problem. We have to show that W is a subspace of V. That means two conditions, that is the vector addition and scalar multiplication. We have to show one of the condition is satisfied, one of the condition will be satisfied, and condition will be satisfied, then that W is a subspace of V. Then one of the condition we are given the condition number 2. Let condition are the KUV belongs to W. That let U is equal to, we are given the vector in that condition A square plus B square plus C square is less than or equal to 0, and let we assume the vector U is equal to 1 comma 0 comma 0 that belongs to W. Why 1 comma 0 belongs to W? Because such that this condition 1 square plus 0 square is equal to 1 plus 0 1, and it's less than or equal to 1, that condition. That's why U is equal to 1 comma 0 that belongs to W, and let K is equal to 1. Then the scalar multiplication, that consider Ku is equal to, K is the 1 and U is the 1 comma 0 comma 0. Then multiplication 1 into 1 1 comma 1 into 0 0 1 into 0 0 that belongs to W. Why? Because that 1 square, but why? Because condition is A square plus B square plus C square is less than or equal to 1, and in that is the A, that is the B, that is the C, and that 1 square plus 0 square 0 0 square 0 1 plus 0 1, and 1 is less than or equal to 1. That's why that 1 comma 0 belongs to W, and therefore that Ku belongs to W, and that condition will be satisfied, and that's why W is a subspace of V. That's why W is a subspace of V. These are the example, and these example are in a question paper in April 2019 or October 2019. 90. These are the example, an important example of the subspace, that to show the W is a subspace, yes or no. Then next example, example number 2. Next example, example number 2. And example is let W consist of those vector A comma B comma C belongs to R for which and that A is less than or equal to B is less than or equal to C, and B is the AB is equal to 0, full stop. Show that W is not a subspace. W is not a subspace. First example we are show the W is a subspace of V, and condition will be A square plus B square plus C square is less than or equal to 1. In that problem, W are the two conditions. First is the A is less than B is less than C, and second is the AB is equal to 0. And we have to show that W is not a subspace. W is not a subspace. Man, we are going to the solution. Then first condition is the A is less than B is less than or equal to C. We are going to the condition is KU belongs to W, and next second problem is then U plus V belongs to W. It is that problem we are use the scalar multiplication, and that problem we are use the vector addition. Then problem number 1, that is the A condition is A is less than or equal to B is less than or equal to C. We use the scalar multiplication, and let U is equal to 1, 2, 3 that belongs to W. Why? Because the condition are given A is less than or equal to B is less than or equal to C, and we are given the vector 1, 2, 3. 1 is less than or equal to 2 is less than or equal to 3, and K is the minus 1. Why K is the minus 1? Because we are show the W is not a subspace. That means that property will not be satisfied. Then consider KU is equal to K is the minus 1, 2, 3. Then multiply by minus 1 into 1, minus 1, minus 2, minus 3, and that does not belongs to W. Why? Because minus condition are the A is less than B is less than C, but condition is the A is less than B is less than C, but that KU is the minus 1 is greater than minus 2 is greater than minus 3, and that's why minus 1, minus 2, minus 3 is does not belongs to B, and therefore KU does not belongs to W, and that's why W is not a subspace. W is not a subspace. W is not a subspace. Then second is the AB is equal to 0. AB is equal to 0. But in that problem, we use the vector addition. That means U plus V is belongs to W or does not belongs to W. But we have to show that U plus V does not belongs to W. Then let the two vector U and V. Then U is equal to 1, 0, 0 that belongs to W. Why? Because condition are A into B is equal to 0, that A, B, C, 1 into 0. 1 into 0 is equal to 0. That's why U belongs to W. Then V, 0, 1, 0, that belongs to W. Why? Because 0 multiplied by 1 is 0. That condition will be satisfied. But that vector addition does not satisfy. That's why that W is not a subspace. Then U plus V, consider U plus V is equal to, U is the 1, 0, 0 plus 0, 1, 0 is equal to 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0. That does not belongs to W. Why? Condition are AB is equal to 0, but 1 into 1 is equal to 1 and does not equal to 0, and therefore U plus V does not belongs to W, and therefore W is not a subspace. W is not a subspace. Full stop.